Hi everybody. We're going to do another ANOVA problem here to follow up from our last video. So in this problem, we've got a table here where we have randomly selected freshmen, sophomores, juniors, and seniors, and we have their GPAs. And the question is, at a 5% level of significance, can we conclude that there's a difference in the means of the GPAs? We're going to make a couple assumptions here that the GPAs are normally distributed and that their variances are equal. So let's just kind of rehash through everything. Let's make sure that we start with our conditions, and let's look back and see what our conditions are again. Our conditions are each sample must be randomly selected from a normally distributed population. Okay, we have that. Samples must be independent of each other. Okay. Well, are they independent here? Well, what do we have? Freshman, sophomore, junior, senior. Is a freshman's GPA going to have any impact on a sophomore's GPA? The answer to that, of course, would be no. So they are independent, and each population must have the same variance. I said that is one of the assumptions that we have in this problem. So our conditions are met. I'm going to save a little time and not write them down. I'll just put check, check, check. We got them all. Okay, so now what? Well, if we go back to our last problem, there's a bunch of things that we calculated for each group. And I'm going to just label these as freshmen 1, sophomores 2, juniors 3, seniors 4. And we're going to just put those in our calculator and calculate and get that information that we need. I'm not going to do it on my computer. I'm going to do it on this calculator here so I can be a lot faster for you guys. If you want to pause the video and put these into your own lists and do the same thing I'm doing, you're welcome to do that. Or if you just want to follow along, totally up to you. So I have already put in the information here. So on my calculator, I'm going to go calculate one variable statistics. I'm going to start for list 1, which is our freshmen. And we're going to get some information here. So X bar 1, 2.69. The sum of the x's, and we need to know that number, 18.86. We need to know the standard deviation, well, actually squared, right? If we go back and we take a look at what we need, oops, I think I went past it. We need the variance, not the standard deviation. So what I'll do is I'll write down this number here for the standard deviation at 0.469, and then I'll square that in just a second. And we also need our sample size here, which is 7. So before I forget that, I'm going to take 0.469, square it, 2.20 would be our variance. So that's the information I needed from our freshmen. I need the same thing from our sophomores, juniors, and seniors. So what I'll do now is I'll go stat calculate one variable statistics. I'm going to switch it to list 2, and I'm going to calculate it. I see it here on my calculator. What I'm going to do now is I'm going to pause my video, and I'll just write in the rest for sophomores, juniors, and seniors finding the same information. All right, so I've got that done now for all 4 groups. Just taking a look and trying to use a little bit of intuition here. I think that this might come back as we're going to reject the null hypothesis that they're all the same. This one is particularly lower, although, I mean, there's quite a bit of variation here, so I'm not sure, but I'm leaning towards possibly rejecting the null hypothesis, and we should probably write that down since we haven't done that yet. Our null hypothesis is that all 4 means are the same. The population mean from 1 is the same from 2, same for 3, and same for 4. Okay. And then our alternative hypothesis was at least one mean is different. And that's actually what our claim here is. Our claim is, can you conclude that there's a difference in the means? So that's our alternative hypothesis. All right, I think we're ready to start doing some calculating. Let's go back to kind of our calculation page here. The first thing we need to find is our grand mean, that x double bar, where we have to add up all the x's and divide by n. And remember, this capital N, big N, is the sum of all the sample sizes. So our x double bar, our grand mean, what we have to do is we have to add up all the x's all together. So this is all the x's for the freshmen, all the x's for the sophomores, and so on. We have to add all those numbers and then divide by our big N, which is all of these added together. So what I'm going to do is I'm going to take 18.86 plus 30.55 plus 25.68 plus 23.68. Okay, so the sum of all the x's, all the GPAs from everybody in this is 98.77. Our total sample size here is going to be what, 1726.34. So when we divide that by 34, get 2.905 as our grand mean. All right, so now what's our next calculation? Our next calculation is to find the sum of the squares between. So that means we need to take the sample size of one group times the difference between that sample's mean and the grand mean squared, and we have to add those all together. Certainly don't have room on this page for it, so we're going to do sum of the squares between. So for our first one, oops, going too far. Sample size is 7 times that sample mean, 2.69, minus the grand mean, 2.905, squared. Oh, excuse me. Now we're going to go to the next one and we're going to add that on. Sample size 10. Sample mean 3.06 minus grand mean squared plus next one. Sample size 9. Sample mean 2.85 minus the grand mean squared plus last one, sample size 8 and 2.96 oops. All right. Okay. So I'm just going to pause the video and I'll just put all that in my calculator. We'll figure out what the sum of the squares between are. All right, so I got 0.615 for the sum of the squares between. All right, what's our next calculation? Sum of the squares within. We have to take basically the degree of freedom, okay, the sample size minus 1, times the variance for each and add those together. So sum of the squares within. All right, first one, the sample size was 7, so we're going to do 7 minus 1 times the variance, 0.220, plus, next one, sample size was 10, so 10 minus 1 times its variance, 0.132, plus, next sample size was 9, so 9 minus 1 times the variance, 0.130. And our last one, 8 minus 1 times its variance, 0.194. All right, I'll pause the video while I calculate that. All right, so for my sum of the squares within, I have 4.906. All right, what's our next calculation? Okay. variance between the samples, the mean squares between, is the sum of the squares between over the degrees of freedom of the numerator. Now, how do we get the degrees of freedom of the numerator? We haven't done that yet. Remember, the degrees of freedom of the numerator is the number of samples minus 1. So, degrees of freedom for the numerator is the number of samples, which is 4, minus 1. So the degrees of freedom of the numerator is 3. How about the degrees of freedom for the denominator? Is the sum of the sample sizes, our big N, which we've already found, minus the number of samples. So remember, our big N on this one is 34. I guess I didn't write that down, but it's right there. 34 minus how many samples? 4 gives us degrees of freedom for the denominator is 30. So again, our next calculation, mean squares between, sum of the squares between over degrees of freedom of the numerator. Okay, sum of the squares between 0.615 over the degrees of freedom of the numerator, which was 3. Yep. Okay, and we get 0.205. Guess I didn't really need my calculator for that one. All right, mean squares within. Mean squares within. Right here, sum of the squares within over degrees of freedom of the denominator. So the sum of the squares within was 4.906 over the degrees of freedom of the denominator was 30. I get 0.164. Finally, okay, we are to our test statistic. Remember, this is an F distribution, and it's the mean squares between over the mean squares within. Okay, so mean squares between 0.205 over mean squares within 0.164 gives us 1.25. All right, so we have to consider our distribution here. Okay, now this is an F distribution, not symmetric. Okay, skewed to the right. We know what this test statistic is, but we have to set our critical region. And how do we set that critical region again? Okay, where did it go? All right, so our level of significance for this one is 0.05. And that's from right here. We have the degrees of freedom of the numerator and the denominator with that level of significance. So remember, this is an F distribution, so we're going to have to go to the back of our book. Make sure that you choose the correct table, which is determined by the level of significance again. So I'm going to go to the 5% level of significance. Here we go. I'm on page A23. The degrees of freedom of the numerator is 3, so I find that across the top. And then I go all the way down to 30, and I see 2.92. So our critical F value, 2.92. So sets that region right there. Our critical F value. Our test statistic is not in there. Okay, so what does this mean for us? We fail to reject the null hypothesis. Okay, so if we look back at our hypothesis, if we fail to reject the null hypothesis, there is not enough evidence to support the claim, okay, that there is a difference in the means of the GPAs.